Okay, in 8.2 we're continuing on, but now we're going to look at equations. I'm going to do one follow-up just from the end of the last one. On the end of this last one, the one thing I want to talk to you about is arctan of negative 3/4 will give you what you want. Sometimes they prefer that your input is positive. So, like let's say the negative 3/4 gave us this. Then positive arctan of arctan of positive 3/4 will give us the angle up here. So another way to write this is 15. And then we'd have arctan of positive 3/4, but this gives us this direction, and we want to go all the way over here. So think about that as it's a whole rotation of 2 pi minus what we have there. So that would be another way to write this answer. Okay, let's move on to polar equations. So 2 different types, right? We're going to convert from the 2 different forms. So first, if we're converting from rectangular to polar, we're going to ideally replace x or y with its equivalent, right? Like x equals r cosine of theta, y equals r sine of theta, and then use identities as needed. So in this case, we've got y equals 7. So we're going to just do r of sine theta equals 7. And you solve for r, so you divide both sides by sine theta, and you get r equals 7 divided by sine of theta. Okay, let's look at the next one. This one's a little bit more complicated because we have both x and y, so we're going to replace it twice. We're going to have r cosine theta equals 3 r sine theta plus 1. Think like you're solving for r, right? So let's move the r's to the same side. So let's subtract 3r sine theta from both sides. And we've got r cosine theta minus 3r sine theta equals 1. Since we're solving for r, the way to get it out of both of those is we're going to factor it out. So we're going to be left with r cosine theta minus 3r sine theta equals 1. And then to get r, I left an extra r in there. It should have come out when I factored it. So 3 sine theta equals 1, okay? And then to get r all alone, we're going to divide by this cosine theta minus 3 sine theta. So your final answer here would be r equals 1 divided by cosine theta minus 3 sine theta. Okay, let's look at this next part. Okay, I'm going to show you 2 different ways to think about this next one. So at first, if we just follow what we have been doing, you're like, okay, I'm going to replace x with r cosine theta, and then I'm going to square it, plus r sine theta, and then I'm going to square it. So then you get r squared cosine squared theta plus r squared sine squared theta, equals 117. You're like, okay, I know what I'm doing. Last time we solved for r, so let's factor it out again. And then I'm left with cosine theta plus sine squared theta equals 117 still. Like, hey, that's an identity I know. I see where they talked about using identities. So this is just 1. So you're left with r squared equals 117. Take the square root of both sides. R equals positive 117. And that would be your complete answer. Okay, let's talk about like a little shortcut. With these, there's some things we know, right? You should be able to recognize that x squared plus y squared equals what in this case? If you think back to the triangle that we did on the last lesson, right? x squared plus y squared equals your r squared. So if you would have recognized that to begin with, I could have replaced my equation when you've got x squared plus y squared equals 117. I could have just replaced this from r squared. Notice we got there anyway, right? We got there right there, but I'm okay if you want to kind of skip that step to then just do, hey, r is equal to the square root of 117. Okay. One last one here. So let's see how it goes. Once again, we've got things that we kind of want to replace. It's going to get a little complicated though, right? If we have like r squared cosine squared theta minus 4r cosine theta plus r squared sine squared theta equals 0, it's going to look a little messy. So let's rearrange this just slightly. I'm just going to put my x squared and my y squared together, and I still have minus 4x equals 0. We just talked about a shortcut, right? We just talked about how we can recognize this x squared plus y squared as what? That's your r squared. And if I just write that as r squared, it looks pretty nice. And then I can do minus 4x is r cosine of theta equals 0. Just like we did before, we want to solve for r. This looks like a quadratic, so let's factor out what they have in common. They both have an r in common. I'm left with r minus 4 cosine of theta equals 0. So think about your factoring. This means that r equals 0, and that's super trivial. That's just going to be a point at the origin, or at the pole in this case, right? But this one is the more interesting one, r minus 4 cosine of theta, which is equals 0. And if you solve for r by adding 4 cosine of theta to both sides, you get r equals 4 cosine of theta. That's your answer. Okay, now we're going to go the opposite way. We're going to have things that are in polar, and we're going to convert them into our rectangular. So, if we've got, in this case, that r equals 7, I would think about r is equivalent to, so if we think about our equation, right, r squared equals x squared plus y squared. That's what we're trying to get it into. So I'm going to write that over here. Well, hey, I'm going to leave x, y in my equation. If r is 7, all I'm plugging in is my radius is 7. And then I've got my polar equation. Usually we don't write that as 7 squared. We'll rewrite it as 49 equals x squared plus y squared. But that's your answer, and you're done. Okay, let's look at the next one. This next one, similar idea. We want to try to get r squared there somehow. Unfortunately, though, like if you think about, hey, if we just squared this side and we squared this side, we'd have like 9 sine squared of theta. That doesn't really help you, because when you plug it back in, you'd have like 9 sine squared theta equals x squared plus y squared, and that's a mess, right? We've got these trig functions with theta on top of our x and y's, and ideally we just want this equation in terms of x and y. So I'm going to teach you a little trick here. When we have r equals sine of theta, another way we can think about this is multiplying both sides by r, and then we do have r squared. Okay, we'll have r squared on the left, and we'll have 3, I'm going to write this a little differently, times r sine theta. At this stage, you may recognize r sine theta as something, right? So r squared is still over here, but we're trying to put these in terms of x and y, and r sine of theta is the same as y. So this would be the same as 3 times y, or 3y on that side. At that stage, I can probably go ahead and replace things. So I'd have r squared, which is 3y, equals x squared plus y squared. You can leave it like this, or what they'll do sometimes is they will rearrange it such that you will get what it looks like in a circle. Don't you guys remember when we studied conics in 1050 where you get like x minus h squared plus y minus k squared equals r squared? So we'd complete the square. This one isn't super nice. We get fractions. Sorry, I meant to change it. I guess it didn't work out for me, but we'd have minus, so x squared plus y squared minus 3y. We're going to figure out a number that completes it equals 0. So to figure out how to complete the square, remember we take this term of -3 divided by 2 and we square it. So we'd have 9/4. Whatever we add to one side, we've got to add to the other. And then this part, right, this trinomial would factor to y minus 3/2 squared. You'll practice that a little bit more in the homework, and there'll be integers, but you will want that practice of completing the square. So x squared plus that equals 9/4 would be another way to write that equation. Okay, 2 more here. So this one, we've got 12 times r equals cosecant. On this one, I would probably just start by rewriting things, because notice if I multiply both sides by r, I'm not going to get r sine theta or r cosine theta, so not super helpful necessarily. So I have 12r equals 1 over cosecant is 1 over sine. So let me just multiply. Let's get everything on the same side and see what we recognize. I'm going to move the 12 out front, but then I have r sine theta. Multiplying those together equals 1. This should indicate something to you. As soon as you get that, you're like, hey, as soon as I see r and sine or r and cosine being multiplied, they should be like, hey, x or y. In this case, that's y. So you're having 12 times y equals 1. Divide both sides by 12. And we end up with y equals 1/12. Okay. One last one here. So we'd have, okay, I meant to change this one. I'm just going to do it here because then it will match the homework a little nicer. So everyone just take your notes out, or if you print it out, you should have a changed version. R equals 1 plus sine of theta. Okay, so on this one, unfortunately, even if I subtract some sine theta, I'm not going to have r times sine theta, so that's not going to work. So let's try and if I multiply that, square both sides, 1 squared plus 2 sine theta plus sine squared theta is not going to give me something super nice. So let's use the trick that we did in the second one, where we multiply both sides by r. Okay, so then we get r squared equals r plus r sine theta. Hey, we like that, right? So r squared equals r, and then r sine theta is our y. That's a good sign. At this stage, okay, well, we know r squared is x squared plus y squared equals r plus y. Let's just get r all alone, so I'm going to subtract y from both sides. And that equals r. Okay, at this stage, this is the part that's a little funky. I don't think you have any this on the homework, if I'm not or maybe you have one like this on the homework. That if you're trying to get r squared over here on the left, because then I can replace it, I can square the left and I can square the right. So then my final answer would be x squared plus y squared minus y squared equals x squared plus y squared. It's another way to write r squared. Pretty crazy, but fun. All right, you should be all set to do all of